So the next function we're going to talk about is what we call our quadratic function, our quadratic key features. And a quadratic is the U shape, and it's a symmetric graph, which means it's the same on both sides. And so when we talk about it, first we're going to talk about how does the graph open? Do the arrows go up like they do in this picture, or do they go down like they do in this picture? Because if it goes up, then we know that we're going to have a low point, a lowest point on the graph. And if it goes down, we have the highest point on the graph. I like to call this low point the floor. You can't go past the floor on this graph right here. And you can't go past the ceiling on this graph right here. And so when we talk about this, we want to talk about what we call a maximum and a minimum. We want to talk about this point itself is given a special name. It's called the vertex. We want to talk about what splits the graph in half. And so when we talk about this, first, let's go through the vertex. The vertex is generally written as the point HK. The vertex is generally written as the point HK. Really, that's just X and Y. The axis of symmetry can be found by the axis of symmetry cuts the graph in half. So if we look at this graph right here, it's cutting the graph at half. And it's cutting the graph at half at this Y value, this X value right here. At X value is where it's cutting it at. So if you notice this, then it's going to be some axis of symmetry will always be a X value. And we write it as X equals, and it's always going to fall at the vertex of H, where H is. So this is just X equals H. And then you have intercepts. Where does it cross the X-axis? Where does it cross the Y-axis? So let's go through an example and talk about the quadratic key features. The first thing I want to know is, does this graph open up or down? Well, the arrows on the graph are going up. So the graph is going to open here. It opens up. And because it opens up, we have a floor or a low point, which we'll call our minimum. The vertex of the graph sits here at the value HK. And that value is just going to be X is -2, Y is -1. So my vertex is at -2, -1. The axis of symmetry, remember, cuts the graph in half, and we're cutting the graph in half at X equals -2. Notice that -2 right here is the same -2 we got in the vertex. That's why we write it as X equals H. The x-intercept of this graph, well, where does it cross the x-axis at? It looks like it crosses the x-axis twice. It's crossing here, and it's also crossing here. And that's because this graph is symmetric. So we know that the intercept for the x value, there is no rise, so our y value will always be 0. So it's -3, 0. And our other value is going to be -1, 0. So the x-intercept here is actually 2 x-intercepts. And most quadratics will have 2 x-intercepts. Some won't, but most will. The y-intercept, where is it crossing the y-axis at now? We see that it's crossing the y-axis here. And that y-intercept, remember, there is no run, it's only rise. That is the value 0, 3. So the last part I want to talk about is our domain and our range. The domain for every quadratic, because if you look all the way to the left, the x values to the left, all the x values to the right. Well, these are arrows, so they're going on forever to the left and forever to the right. So our domain for every quadratic will be all real numbers. Our range is dependent on if we have a floor or a ceiling. If we have a floor, then our range is going to be, y has to be, we can't go below the floor. So we can only go up from the floor. So y has to be greater than or equal to whatever our floor value is. If we have a ceiling, well, if you look at a ceiling, you can't go past the ceiling, so you have to go below it. So that means y is going to be less than or equal to whatever your ceiling value is. So in this particular problem, we have a floor. We can't go past this value of -1. So y has to be greater than or equal to -1. And again, because we have a floor, you have to be above the floor. Let's look at another one. So in this particular graph, again, we want to identify, does it open up or down? When we look at the graph, the arrows are going down. So it opens down first. It opens down. And because it opens down, we have a ceiling or a high point now. So that's going to be a max value that we're getting there. The max always occurs at the vertex of the graph, and the vertex is the value HK. In this case, our max is going to be 1, 2. So our vertex is 1, 2. The axis of symmetry cuts the graph in half at the vertex. And we write it as a line as x equals 1. The x value equal to the h value in this case, 1. Our x-intercepts is crossing the graph here at a half, a negative 1/2, and here at 2.5. So our x-intercepts are going to be, remember that y value is always 0 there, so we have negative 0.50 and 2.50. The y-intercepts, well, it's crossing the y-axis here at 0, 1. The domain for every one of these functions is all real numbers. Every quadratic is all real numbers. The range of the function, we have a ceiling. You can't go past the ceiling. So you have to be below that ceiling. So we say that the range of this function is y less than or equal to, and its ceiling is set at 2.